Greetings everyone, you are welcome in this video tutorial. In this video tutorial, we will talk about stacks in C++, especially infix and postfix operations. Let us understand what are the applications of stack. We have already discussed what is a stack and its various operations. Now in this video, we will discuss about the applications of stack. A stack is an appropriate data structure on which information is stored and then later retrieved in reverse order. You know, the data which is inserted last is the one which is retrieved first. So the whatever information we store in stack, that is always retrieved in reverse order. Now the application of stacks are as follows. When a program executes, stack is used to store the return address at time of function call. So you can see here I have made a small diagram for this. Suppose there are two functions, func1 and func2, and this is the main function. In the main function, we are calling the function func1, and when we jump to the func1 function, we see there is again another function called func2. Now let us see how it actually works when we execute this program. So all the three functions, they get separate memory spaces. They are defined in separate memory spaces. From main, we are jumping to func1. From func1, we are jumping to func2. And after the complete execution of func2 function, the control jumps back to func1. And when the execution of func1 completes, the control jumps back to main. Now the question is how the operating system keeps track of everything to where it has to go after the execution of one function. So to keep track of where the program control has to jump from one place to another, operating system uses stack. You can see here. Now in first the execution always starts from main. So the address of main function is pushed first in the stack. Now when the control jumps from main to func1, the address of func1 will be stored in the stack. Now when the func1 will call function func2, the address of func2 will be stored in the stack. You can see here, first func1, then second is func2, and the third is second is func1 and the third is func2. Now after the complete execution of func2, it has to go back to func1. Now how will operating system comes to know where is func1 stored? So for this, after the completion of func2, the address, the func2 will be popped out from the stack, and the top of the stack is now func1, which is the address where the operating system has to, where the program control has to come back to. So it can easily locate where the operating system has to come after completing the execution of func2. So it can see the address of func1 from here and it will go to func1. And after the complete execution of func1 will be popped from the stack. Now operating system can easily find the address of main, which is stored here. So from func1, it will jump back to main. So this is how jumping from one function to another function takes place in C++. So you can again see when a program executes, stack is used to store the return address at the time of function call. And after the execution of the function is over, return address is popped from the stack and control is returned back to the calling function. So this is what I have explained in this diagram also. Now stacks are also used to convert an infix expression to a postfix operation and to evaluate the postfix expression. Reversing an array, converting decimal number into binary number, etc. are some other applications of stack. Now let us see what are infix and postfix operations. Now the infix expression is a conventional algebraic expression in which the operator is in between the operands. So whatever expression we write in mathematics in our daily life, they fall in infix expression category. We simply write an operator in between the operands. So if there are two operands A and B and we want to add them, the expression will be A plus B. And you can easily see that the operator is in between the operands A and B. So this is an example of infix expression. Now in the postfix expression, the operator is placed after the operands. So if we want to write A plus B in postfix expression notation, it will be AB plus. It means we have to perform plus operation on the operands A and B. So this is the postfix notation. Now, what is the need of postfix expression? Why are we studying postfix expression? Postfix expressions are really special because they do not use parentheses. In postfix expression, we never put parentheses. And the order of the expression is uniquely reconstructed from the expression itself. So, whenever we have to solve any mathematical expression which is written in infix notation, we have to use the BODMAS rule. Now, computer does not know what is BODMAS and it cannot apply the BODMAS rule on its own. So, we convert every infix expression to postfix expression in the computer, because the order is, if they are written in a special way in which BODMAS rule is not required, and they can be solved correctly without the usage of BODMAS rule. So, they are very important in computers. Every infix expression needs to be converted to postfix expression. So, these expressions are useful in computer applications. Now, let us see how we can convert an infix expression to postfix expression. So, we have written an algorithm here. So, suppose the name is convert IP infix to postfix, and we are passing an infix expression here. P is the postfix expression, and stack is an array which we will use to convert infix expression I to postfix expression P. So, let us see what are the steps. Step 1, we will first push left parenthesis into the stack and add right parenthesis to the end of infix expression. So, whatever infix expression is given to us, we simply push left parenthesis into the stack and we add right parenthesis at the end of that. Now, we scan expression I, that is the infix expression, from left to right and repeat steps 3 to 6 for each element of I until the stack is empty. Until your stack is empty, we repeat steps 3 to 6 for all elements of the expression I. Now, if scanned element is equal to left parenthesis, we simply push it into the stack. If the scanned element, the element which we are scanning, is equal to the operand, we add it to P, that is the postfix expression. And if the scanned element is equal to operator, then what we have to do? We repeatedly pop from stack and add to P each operator from the top of the stack until the operator at the top of the stack has lower precedence than the operator extracted from I, or the operator which we are scanning currently. So, what we have to do? We have to check the priority of the operator which we have recently scanned with the operator at the top of the stack. And if the operator which is present at the top of the stack has more or equal priority or precedence, you can say, then it will be extracted from the, it will be popped from the stack and it will be added to P. And then last, the scanned operator is pushed to the top of the stack. Now, if scanned element is equal to right parenthesis, then repeatedly pop from stack and add to P each operator until the left parenthesis is encountered. So, you have seen earlier that we have simply pushed the left parenthesis, and now if the scanned element is right parenthesis, we will repeatedly pop from the stack and add all the operators which are present in the stack to P until the left parenthesis is encountered. And lastly, we will pop the left parenthesis also, but we will not add it to P. It is simply popped out. So, this is the algorithm. So, if we let us work on some examples so that it will become more clear. Now, let us see an example. We have to convert the infix expression to postfix expression. And in this, the expression is, you can see, is the logical expression in which true, false and logical operators are used. And this is an infix notation, and we have to convert it to postfix expression. Now, you can see that I have inserted one left parenthesis and right parenthesis here. First, the left parenthesis will be pushed to the stack. This is the scanned symbol, is this left parenthesis. This will be pushed to the stack, and the status of the stack is, this has already been pushed, and now the status of the stack is, we have two left parentheses, and nothing has been added to postfix expression P till now. Now, the next element which is to be scanned is true. So, this is the scanned symbol, you can see. Now, whenever we encounter operands, they are simply added to the postfix expression. They are not pushed into the stack. So we will add it to P and stack will remain the same and the expression P now contains true. Now the next is the operator AND. This is the symbol of AND operator. So this is the symbol you have scanned and we simply push it into the stack because you can see that top of the stack contains left parenthesis and it is not an operator. So we do not need to check the priority. We simply push it into the stack and our postfix expression will remain the same. It is true. Now the next scanned symbol is false. So we see that this is the false and again this is an operand. So we will simply add it to P. Stack will remain the same and now the expression is true. True was earlier there and now false will also be added to P. Now you can see the next scanned symbol is right parenthesis. See, this is the right parenthesis. So whenever the right parenthesis is encountered, we have to pop from the stack all the operators and add to P until the left parenthesis is encountered. So this is what we are doing. See, the top of the stack at present is double ampersand, that is AND. So we will pop this operator and add it to P. See, that it has been added. Then we will pop another symbol. The next top is the left parenthesis itself. This will be simply popped and this will not be added to the postfix expression. So postfix expression will remain this and this is the status of the stack. Now the next scanned symbol is OR operator. So when the OR operator is encountered, we will push it into the stack because in the stack there is no operator, only left parenthesis is there. So there is no priority checking. So we will simply push it into the stack and our postfix expression will remain the same. Now the next scanned symbol is exclamation mark, which is a NOT operator. So this is the NOT operator. Again this is an operator. So we will first check the priority of it. Priority which is of the symbol or the operator which is present at the top of the stack at present is OR and priority of NOT is more than OR. I hope you know the priority of logical operators. NOT has the highest priority and 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 OR, they have the same priority and they come after NOT. So NOT has more priority than OR. So OR will not be popped out and we will simply push NOT operator and the postfix expression will remain the same. Now the next is the left parenthesis. See, to left parenthesis we will simply push it into the stack. So now stack looks like this. We have left parenthesis, OR operator, then NOT operator and again the current scanned symbol which is left parenthesis. And the postfix expression remains the same. There is no change. Now the next scanned symbol is false. This is an operand. So this is simply added to P. Stack will remain the same. And now our postfix expression is true, false and false. Next scanned symbol is OR. OR symbol has been encountered. So before pushing it into the stack, we will check for the top of the stack. The top of the stack is left parenthesis again. So there is no priority checking. We will simply push it into the stack. And our postfix expression will remain the same. Now the next scanned symbol is true. You can see here. So this is an operand again. So this will be added to P and the stack will remain the same. And now the postfix expression is true, false and false, true. Now the next scanned symbol is left parenthesis. You can see here left parenthesis. So when the right parenthesis. So when the right parenthesis is encountered, we will start popping from the stack until the left parenthesis is encountered in the stack. You can see here the topmost element is an OR operator. So this will be popped and this will be added to P. This will be added to P. Now the next is the left parenthesis itself. So this will also be popped from the stack, but this will not be added to P. Again we have encountered one more right parenthesis. So again we will start popping the operators from the stack until the left parenthesis is encountered. So this is the top of the stack. So we will first pop NOT operator and add it to P. So you can see here this has been added here. Then again we will pop the next operator which is OR operator. Again we will add it to P. This has been added here. You can see here. And after this left parenthesis has been encountered. So this will simply be popped and you can see the contents of the stack are nil down. So our conversion will stop here and the final expression is true false and false true or not or. So this is our final postfix expression of this infix expression. Now let us see one more example of converting infix to postfix expression. We have this expression now, this time the simple mathematical expression a plus b into c minus, in the brackets we have d plus a, and then we have this is the power sign which we call as caret, and e. Now let us see how this expression can be converted to postfix expression. Now this time we have used a separate method. Whatever method you like, you can choose any of these two methods. Now this time I am using stack. So I made a stack like this. And the first element which is encountered is A. So A is an operand. So this will be added to postfix expression. So this is my postfix expression, and my stack remains empty. Now next is an operand plus. So plus will simply be pushed into the stack because stack is empty right now. There will be no comparisons, and postfix expression will remain A. Now the next scan symbol is B. B again is an operand. So this will be added to postfix expression. You can see here, and this is the content of the stack. Now the next scan symbol is multiply sign. So we will first check the priority of the stack. So the topmost symbol which is present in the stack is, you can see, plus, and multiply sign has more priority than plus sign. So you know, in the if we talk about the mathematical expressions and operators, the topmost priority is caret or the power sign, and then you have multiply and divide at the same priority, and after that plus and minus at the same priority. So multiply sign has more priority than plus, so it will simply be pushed into the stack. The next symbol is C. C again is an operand, so this will be added to P without any changes in the stack. Stack will remain the same. Now the next scan symbol is minus. So minus is first compared with the top of the stack. Now at the top of the stack we have the operator multiply, and multiply has more priority than minus sign. So this will be popped from the stack and added to the postfix expression. And then minus is compared with the topmost element, which is now plus. Now plus and minus have the same priority. So again plus will also be pushed. If they have the same priority, in that case also the operator is popped and it is added to the postfix expression. Now the stack has become empty, so we will simply push minus into the stack like this. Now the next scan symbol is left parenthesis. So we will simply push it into the stack. There will be no change in the in the postfix expression, and two steps have been done here. I have scanned the next symbol D. So D is also added to the postfix expression because D is an operand. Now the next symbol is plus. Plus symbol is an operator. So we'll first compare it with the top of the stack. Top of the stack has left parenthesis. So there will be no popping and pushing. It will simply be pushed into the stack. Plus will simply be pushed into the stack. And the next symbol is A, which is an operand. So this will be added to, you can see here, to the postfix expression. And my stack remains the same. Now the next symbol is right parenthesis. So whenever the right parenthesis is encountered, all the symbols from the top of the stack are popped until the left parenthesis is encountered. So you can see here at the top of the stack we have plus symbol. So this will be popped and added to the postfix expression, and then the next symbol is the left parenthesis. This will simply be popped from the stack and it will not be added to the postfix expression. So the next symbol we scan is the caret sign or the power sign. So this has the highest priority. So if we compare it with the top of the stack has minus sign, which has lower priority. So we will simply push caret into the stack, and my postfix expression will remain the same. Now the next symbol is E. So I will simply add it to the postfix expression, and you can see here that my postfix expression has ended here. Infix expression has ended here. So now the next step is to pop all the symbols which are present in the stack. So I will simply pop all the symbols. The first symbol is the caret sign. This will be popped and added to the postfix expression, and then minus will also be popped and added to the postfix expression. So this is my final postfix expression, which is also written here: A B C star plus D A plus E cap minus. So this infix expression has been converted to this postfix expression. So next is how we have to learn how to evaluate the postfix expression, how postfix expressions are evaluated. So we have written an algorithm here to understand this. So the name of the algorithm is evaluate. We are passing P, which is the postfix expression, the result, which is the final result of evaluation of the postfix expression, and stack, which is the stack as an array, which we will use for the evaluation of postfix expression. So let us see the steps. Step 1 is scan the postfix expression P from left to right and repeat the steps 2 and 3 until the stack is empty. Now step 2 is if the scanned element is equal to operand, push it into the stack. If we encounter the operand earlier in while converting the infix to postfix, we were pushing the operator into the stack. Now this time we will push the operand into the stack. And if the scanned element is equal to operator, then we pop the topmost operands like with operand A and operand B. Suppose these are the two operands which are present in the topmost positions of the stack from the stack, and then we evaluate operand B. Very important to notice operand B, the current operator which we have scanned, and then operand A. We perform this calculation, and the result of this calculation is pushed into the stack. And when the expression ended, we will be left with the result, only the result in the stack, and that result will be the topmost element of the stack, which will be popped from the stack. Now let us understand this with the help of an example. So we have taken two examples, one for the logical expression and one for the mathematical expression. So suppose this expression is given to us in the postfix form. We have true, false, or false, true, and not, or. And we have to evaluate this expression. So let us see how my contents in the stack will look like. Now the first symbol is true. So this will be this is an operand. So this will be added to the stack. Now this since the stack is empty, like they simply have to be, we simply have to insert them. There is no priority checking in the case of evaluation of postfix expression. Now the next symbol is false, which again is an operand. So this will also be added to the stack. So no operation is performed, they are simply added to the stack. Now the next scanned symbol is OR. This is an operator. So we will pop the topmost element, two topmost elements of the stack, and apply this operation. So you can see the topmost elements are true and false. So they will be popped, and this operator OR will be applied to them. So true or false is true. I hope you remember this table. So true or false is true. So the result is true, and this true will be pushed into the stack. So my stack now contains true. The next scanned symbol is false. As this is an operator, this will simply be pushed into the stack. The next scanned symbol is true. As again this is an operator, this will be simply pushed into the stack. Now the next scanned symbol is AND operator. Now this is, these two are operands. Now add operator. So in the case of operator, we will again pop the topmost elements from the stack. Now the topmost elements are false and true this time. So they will be popped, and this operator is applied to them, AND operator. So this becomes false and true, which is false. So we are left with true earlier, and now false will be pushed into the stack. Now the next symbol is again a NOT operator. So you know NOT operator is a unary operator. So only one element will be popped from the stack. In the case of binary operators, two operands are popped, and in the case of unary operators, only one operand is popped. So only the topmost operand will be popped, that is false. So this operation is applied, not false, and it will become true. So true will be pushed into the stack. We earlier had true in the stack, and now we have one more true. Now the next operation is OR. So we again apply the pop the two operators. There are only two operands. There are only two operands, true and true. They will be popped from the stack, and we apply this operation. It will become true or true, and the result of this is true. So this will again be pushed into the stack, and you see our expression has ended here. So this is the result of this of the evaluation of this postfix expression, and this will be popped from the stack. So this is our result, you can see. Now let us consider one more example, and we will do it in another way like this. Now this is a mathematical expression which is given to us, and these are the values of A, B, C, D, and E. So let us evaluate it. Now the first scanned symbol, as you can see here, is A. So A is an operand, so it will be pushed into the stack. The next scanned symbol is B. B again is an operand. This will be pushed into the stack. Next symbol is C. C again is an operand, so this will be pushed into the stack. Now the next scanned symbol is the multiply operator. Now this is an operator and this is a binary operator. So we will pop the latest two, topmost two operands from the stack and apply this operation. So B and C will be popped and the operation will become B into C. And you can see the value of B is 5 and the value of C is 2. So 5 into 2 is applied and it will become 10, and then 10 will be pushed into the stack. The next scan symbol is plus operator. So again, we will pop the topmost operands from the stack. Topmost elements of the stack are 10 and A, and this operation is applied. So it will become A plus 10 as plus symbol has been scanned, and the value of A you can see is 1. This will become 1 plus 10, which is 11. Now you can see the next scan symbol is D. So 11 has been inserted into the stack, and the next scan symbol is D. So D will also be pushed into the stack. The next scan symbol is A. Now the A will be pushed into the stack because this is also an operand. The next symbol is plus, which is an operator. So again, the topmost operands will be popped from the stack, and the topmost operands are D and A, and this plus operation is applied. So it becomes D plus A, and the value of D is 3 and the value of A is 1. So D plus A becomes 4, and this will be pushed into the stack. Now the next scan symbol is E, which is an operand, so it will be simply pushed into the stack. And the next scan symbol is a caret symbol. So this is a power symbol. So we again pop two topmost elements on the stack, which is E and 4, and this will be 4 caret E. It will not be E caret 4. It is always the second symbol first and then the first symbol. So 4 caret E, which becomes 4 caret 1, which means 4 to the power 1, and it becomes 4. So 4 will simply be pushed into the stack. And then the next symbol is minus, which is again an operator. So this operator is a binary operator. So we will pop two operands 4 and 11, and the operation is performed. So this will become 11 minus 4, which is 7. So 7 is pushed into the stack, and you can see that my expression has ended here. So this is the last element of the stack which will be popped, and this is my final result. So this is all for this session. I hope you like this video, and if you like it, please give thumbs up, and you can also subscribe to my YouTube channel. Thank you.